Now the model that we have seen so far is like this. So you have got yijk, mu plus alpha plus beta j, etc., where the epsilon ij's are IID with normal 0, but I have written sigma square e. The reason for this extra subscript e will be clear in a moment. Now I said that here I am not really interested in these beta j's, because the beta j's are not really like fixed entities. They represent villages, the j's village. Now j's village of what? I am not making a complete enumeration of all villages. I have just picked up some random villages, some representative villages. So I would like to consider beta j also as a random quantity. So basically the idea is that j is a random quantity and beta is the corresponding effect of that randomly chosen village. To reflect that, I will put this assumption. Beta j is again itself a random variable. So I have got beta j IID normal 0 sigma square b. That is why I call that sigma square e, just to distinguish between these two variances. And I have not written it. I also assume that these things are independent, which is very natural, because those are just measurements, there are some things like that. So why should that be related with this? So we are assuming that these two things are independent. So that is my new model. Now when I write it in this way, it is customary not to write Greek letter beta, because beta ceases to be a parameter. So we typically use English letter b. So alpha I, that remains a parameter, unknown parameter. These are random quantities and they have got this distribution. So this way of modeling mimics more closely our thought process behind the entire thing. So we know that the villages are chosen randomly. So their effects must be random quantities. But the two varieties, they are not chosen randomly. They are of the main importance. Whoever is going to use the report will be interested in specifically those two varieties. In this case, I will also allow my sigma square b to be equal to 0. So that will be the special case, the sort of the degenerate case, which says that villages do not have any effect at all. So the assumption that all beta j's are same now has the corresponding analog that sigma square b is equal to 0. So that measures, sigma square b measures the variability among the villages. We are not interested in the specific effect of villages, but we are interested in the overall effect of the villages. And it will be important to know whether villages have any effect or not. Then we can test whether sigma square b is equal to 0 or not. Now in such a model, these b's are called random effects. Obvious reason, they are random. So in contrast, we should call these alphas our fixed effects. A linear model which has both random effects and fixed effects is called naturally a mixed effect model. So if we have only fixed effects, like all the examples that we have considered so far, in that case we will call them fixed effects model. So all our models considered so far are fixed effects model. If we have only random effects, then similarly we shall call them random effects model. In most cases we have both of them, like in this example, that will be mixed effects model. So in the next video we shall see why these are really useful and what is the additional computational burden when we are considering this model.